Okay, so here's your lesson on 30, 60, 90, 45, 45, 90 right triangles. Otherwise, we talk to you about, or they're known as special right triangles. They're special because there's a really unique relationship between the three sides of each of these triangles, and they can be very useful going forward into not only just using them to find missing pieces of special triangles, but also going forward in our ability to develop trigonometry, the sine, the cosine, and the tangent, especially as you hit algebra 2 and pre-calculus. Okay, so the 30, 60, 90 is kind of where I want to start. I got a unique way that I like to go about this. So there's a right triangle, we've got a 30-degree angle and a 60-degree angle. Now, we're already coming off of Pythagorean theorem, and remember that in Pythagorean theorem, we didn't really know the angle measures, except that we know we have that 90-degree angle, and that my request for you was leg, and hypotenuse, with the hypotenuse always being the longest side, or the side opposite the right angle. So there's our right angle right here, the side opposite of it being the hypotenuse, and that the relationship there was that leg squared plus leg squared equals a hypotenuse squared. And so that's definitely one relationship that we have with right triangles. Now in this one you needed to know two of the sides to find the third. Okay, so any of that work we were doing to find a missing side of a right triangle required us to know two. In the special right triangle setup, we only need to know one of them. Okay, but before we get jumping into that, let's talk about naming some parts. Now, obviously, we still have a 90-degree angle, and the side across from it is still going to be the hypotenuse. Okay, we have two legs, but we do have a relationship with them now. We learned a couple months ago, possibly, that the shortest side of a triangle is always across from the smallest angle. And therefore, if we've got this 30-degree angle here, the side across from the 30-degree is going to be what I'm going to term as the short leg. And then the side across from the 60-degree angle then would be obviously larger than the 30. It's smaller than the hypotenuse. I'm going to call it the large leg. And for me, those relationships or those names are important as we go forward, being able to define the relationships between the three sides. You're going to see me abbreviate these. Short leg, I'm going to do as SL. Hypotenuse, I'm going to do as H. And long leg or large leg, I'm going to do as LL. Okay? So let's go through a little bit of some samples with this. So here's a right triangle. I'm going to define that as 30 degrees. Okay. Here's the short leg. Here's the long leg. Here's the hypotenuse. I suppose I should put the relationship out to you first. Here's the connection. The short leg will always be half the hypotenuse. Always. And that is only, again, in cases where we've got that 30-degree angle. So we could say that the short leg equals the hypotenuse divided by 2, or the hypotenuse is 2 times the short leg. So there's one relationship. So if you knew the short leg, you now automatically know the hypotenuse. It's double the short leg. If you knew the hypotenuse, you would know the short leg. It's half of the hypotenuse. Okay? Long leg is not as cool, not as easy, but the long leg is going to equal the short leg multiplied by the square root of 3. And in reality, these are just something that, hey, you should use them enough to where you know it, or have a pretty good recollection about them so that you can look them up really quickly. So forth. The short leg, coincidentally, is the long leg, square root of 3 divided by 3. There's a little bit of algebra. Basically, we solved this for short leg by dividing both sides by the square root of 3, which would have given you long leg over root 3. Then we multiplied each the top and the bottom of that fraction by the square root of 3 in a process called rationalizing the denominator. All that you don't need to know. You just do need to know that the short leg is going to be long leg root 3 over 3. Now these relationships are always true in a 30, 60, notice I unlabeled it, 90 right triangle. Okay, so that's just fact. All right, so let's take a couple examples here. Okay, and I'm going to start skewing my triangles here. I'm going to put the 30-degree angle down there, 60-degree angle down there. In this particular case, I'm going to call that 5. Let's see, this is going to be example 1. I'm going to do an example 2. Let's see, we're going to go like this. 30, 90, 60. Okay, in this one I'm going to give you 6. Okay, so two very different examples. You have to do a little bit of identification, a little bit of thinking here first. So here's the 30 degree. The first thing that I would say is classify my known side. Is it short leg, long leg, or hypotenuse? Well, in this case, here's the 30-degree angle, and the side across from it is 5. That's going to be the short leg. So I'm just going to note to myself, hey, that's the short leg. Okay. So this would then be the hypotenuse. That would be the long leg. That helps me keep everything laid out. And then I can use my rules. And I kind of approach it as the short leg is the key. If I know the short leg, then the short leg will directly lead me to the hypotenuse, and it directly leads me to the long leg. So again, referencing my rules, where I know that the hypotenuse is 2 times the short leg, and I know that the long leg is the short leg times the square root of 3, I can use these to complete this and just say, well, okay, the hypotenuse is going to be 2 times 5, or 10, done. The long leg is going to be the short leg, which is 5 times the square root of 3, done. Okay? And if we were to go into the Pythagorean theorem, you know, hey, we see that's 10. We've got this as 5 root 3. If we put these all into the Pythagorean theorem and just get a little quick double check, 5 squared plus 5 root 3 squared, does it equal 10 squared? Okay, well, we can do this really quickly. 5 squared is 25. 5 root 3 squared, well, we're going to square the 5. That's going to give me 25. Root 3 squared is going to give me regular 3, and 10 squared is going to give me 100. And I can see right there, 25 times 3, oh, that's 75. And in fact, Pythagorean theorem checks this out to the point where we can say, hey, that must have worked. My 2 leg squareds equal the hypotenuse square. Okay? But really, all you're responsible for in this kind of a situation is that. What are the 2 other sides that we don't know? And again, I'm going to keep emphasizing, these only apply to 30, 60, 90 right triangles. These don't work for every possible right triangle. Okay, they have to meet those angle measurements. Okay? Well, let's jump over to this one. Here we've got a 6. 6 is across from the 60. Well, that makes that the long leg. And that's not as easy for us to deal with. Here's the short leg, here's the hypotenuse. We want those 2 values, okay? But now we're going to be using these rules. Well, the short leg equals the long leg, root 3 divided by 3, and the hypotenuse is 2 times the short leg. So again, the short leg is the key. Short leg is what I want to get first. I can't get the hypotenuse till I know the short leg, so there's going to be kind of a rotisserie kind of a deal here. Take the long leg, get the short leg, take the short leg, get the hypotenuse. Okay? So the short leg, long leg, root 3 over 3, well, the long leg is 6. So the short leg is 6 square root of 3 divided by 3. Make a quick check of 6 and 3. Well, 6 and 3 are reducible. So 6 divided by 3 is 2. We've got 2 root 3. So my short leg is 2 root 3. Done. Okay? Now the short leg is the key, because the hypotenuse is 2 times the short leg, and the short leg was 2 root 3, so I took that short leg, dropped it in place of SL, right there, 2SL. Okay, well, 2 times 2 root 3, well, I can multiply the things on the outside, and I can say, hey, that's 4 root 3. So the hypotenuse is 4 root 3, the short leg is 2 root 3, and there we go. Two very similar but different examples, just depending on which piece you're given to start with. Now obviously you could be given the hypotenuse to start with. I'll run through that really quickly. Okay, an example where, all right, here's my 90. I'll just say that's my, whoa. Okay. I'll just say that's my 60 degrees, and I throw that out at 25. I picked an odd number, of course. Okay, well that's my hypotenuse. Here's my short leg, here's my long leg, because if that's 60, that implies that has to be 30. And a lot of times they're only going to give you one of them, and as soon as you see the 90 and the 30, you can jump to the fact that the other one is 60. Okay, well the short leg equals the hypotenuse divided by 2. So that's going to be 25 over 2, which first off we could leave it like that. If you're uncomfortable with that, that's 12.5. But the short leg is the key. Once I knew the short leg, then I can get the long leg, because the long leg is the short leg root 3, which could either be 25 over 2 root 3, which I could be done with, or if you like, 12.5 root 3. Either way. All right, so that was the 30, 60, 90. You do also have a 45, 45, 90 setup, which is actually easier than 30, 60, 90 in my estimation. If you look at that really closely, you might say, hey, that's an isosceles triangle, where these two legs are the same. So I don't have to differentiate between a long leg and a short leg. Now I'm just going to say those are each legs, and that's a hypotenuse. So whatever this length is, it's the same as this length. So if I know that's 8, I know that's 8. Okay. The hypotenuse in this case is going to turn out to be the leg times the square root of 2. And then if we went the other way and solved that for leg, divided both sides by root 2, and then rationalized, the leg is going to be hypotenuse square root of 2 divided by 2. Now, you only need to use one of them just depending on what it is that they give you. So, some examples. We'll do 2. Let's do a 45, 45, 90 where they tell you the hypotenuse is 10. And let's do a 45, 45, 90 where they tell you the leg is 7. Like I said, these are a lot simpler. Here you're still going to identify what is it. Ask yourself, what is it that I know? Well, I know that is the hypotenuse. That makes these legs. And it says that leg is hypotenuse root 2 divided by 2. Well, I know the hypotenuse is 10, so that 10 is going to drop in there. 10 root 2 divided by 2. 10 and 2 also seem to reduce, and we would go with 5 root 2 and leave it. Okay, and again, I didn't even talk to you about, hey, let's not simplify these radicals. Let's stay away from our calculators. All right, so that means this leg is 5 root 2. It also means that leg is 5 root 2. Okay. All right, here we do our identification. That's a leg. Well, we know that's a leg, and that's a hypotenuse. Well, this is easy. That's 7. Has to be, because we have an isosceles triangle. The hypotenuse, leg root 2, 7 root 2. Done. So, you know, it works out pretty simply. Okay. Got one final example for us today. Okay. And it's a triangle that's basically put together with a 45, 90, 45, or 45, 45, 90, and a 30, 60, 90. I'm going to pick a piece to give you, and it should open up the door for everything. I'm going to throw 12 right there. And I'm going to find X, Y, Z, and W. Okay? I would highly tell you to ignore the X, Y, Z, and W and say, I gotta find those in order. And I would go to my world and say, okay, pretend this doesn't exist. Here's 30. Oh, that makes this the short leg. It makes that a long leg, and it makes that a hypotenuse. So the hypotenuse is known. So I'm gonna figure out these two parts first off, okay? So the hypotenuse being 12, the short leg is gonna be hypotenuse divided by 2, or 12 over 2, or 6. Okay, so I just determined this is 6. I just found x, so I'll keep track of that over here. X is 6. The long leg down below here, so long leg, so the long leg is short leg root 3, so that's going to be 6 root 3, because the short leg is 6. So I just found this to be 6 root 3, so I'll keep track of that over here. Y is 6 root 3. Okay? Well, now if I flip-flop to this triangle, because I've completed this triangle, if I flip-flop to this triangle, 6 is not only the short leg, but it's the leg of that triangle, which means that's also a leg, which means if that's 6, this is 6. All right, so that means Z is 6. And then W, well, we've got a 45, 45, and 90, and a 6 and a 6. Well, W, which is the hypotenuse, is going to be, no, not short leg. The hypotenuse is going to be leg root 2. So W is going to be 6 root 2. So W, 6 root 2. And there's how we go about multi-step finding, hey, we know one piece of this big figure, but we know some angles, and we can work our way through the 30, 60, 90 and basically build ourselves our answers in that regard. Okay, so that should get you started with 30, 60, 90 and 45, 45, 90 right triangles. Okay.